Back to chapter 5, Thevenin equivalent circuits group. So we already examined what is Thevenin equivalent is and the some information that we need in the calculation of Thevenin voltage and resistance. So in this video we will be seeing these VTH, RTH calculations. Let's start from the VTH calculation. So this is the circuit given to us and asked find the Thevenin equivalent circuit with respect to terminals A and B. So that means we're going to find these two elements which are connected next to each other in serial. So how we are going to calculate this VTH value? We are going to examine the circuit here. If A and B terminals open circuit, that means no passing through current here. This current is 0 means RTH current is 0. That is Kirchhoff current law equation. If the RTH current is 0, definition relation, this voltage is also 0. If this voltage is 0, VTH is equal VAB. So we found the way of calculating VTH in the circuit given to us. So that is the circuit given to us. We are saying if A and terminal is open circuit, then we are going to calculate VAB voltage in this given circuit. This voltage is going to be my Thevenin voltage. So how we are going to calculate it is easy. Now we turn the problem to find an element voltage here in the given circuit when these terminals are open. So that means analysis of a circuit given to us. This is that circuit. So this is the equations that we wrote here. It says minus 30k times I. So that's voltage, isn't it? And that is 30k I. So this is the I. So we are talking about VTH here. That's okay. So this current is equal to 0. So this 10I current is this current, isn't it? So this current is the opposite direction. If you write the Kirchhoff current law equation for this node, the 3k ohm resistor current is minus 10I. Multiply this 3k is going to give you this voltage. This voltage is that V. V is minus 30k I. So what is I? If you look at this here, what is I here? This node voltage minus this node voltage, 8 minus 3 VTH. So this voltage here, 3 VTH, because we know VAB is that V, 3 times VAB is 3 VTH. So I wrote that's 3 minus 3 VTH, which is the same as 3k voltage. If you divide this to 10k ohm, you're going to find that current. So I replaced that I with this I. So if you do the calculation, you're going to end up with VTH is equal to 3 volts. So we found this voltage between terminals A and B when these terminals are open circuited. And we already said that this open circuit voltage is the same as VTH, so we have found the VTH. So we have done one part of it. The second, come to this frame, see the frame altogether. In here we have calculated VTH. Now we are going to calculate the RTH, which is the second element value in the Thevenin equivalent circuit, and this is going to be an alternative calculation for RTH. There is no any alternative calculation for VTH, but there is one for RTH. And then we are going to mention the Norton equivalence once we have found the Thevenin equivalent circuit. So let's come to the Thevenin resistor calculation. How we are going to do it? In the voltage calculation, Thevenin voltage calculation, we made the terminals A and B open circuit. Now we are going to make it short circuit. So A and B terminals are short circuited. When it is short circuited, the voltage becomes zero, but there is going to be a current passing through. That current is the short circuit current, that SC is for the short circuit. We are going to calculate that current. Now we are saying if you calculate this current, you can calculate the RTH. How? VTH already we calculated, that is. If you made this short circuit, this one, that means RTH is going to be the voltage of RTH as well. VTH is going to be the voltage of RTH resistor as well. So voltage is known, so you can find the current of this resistor. So the voltage over the resistor gives you the current of this element. Current of RTH is also the short current of my circuit. This short current is the thing that I would like to calculate. So once you found this, then RTH is equal VTH over ISC. VTH already we calculated. ISC, we just said how we can calculate it. For the given circuit, we are going to short circuit the terminals A and B and calculate this short circuit current. If we do this calculation, then we can find out RTH. So the problem transferred to another problem of finding a current within a circuit. So we know the circuit analysis, we could do any method we like and then find out this current. So how we found it, it is easy, you can see it here. When this voltage is 0, that means that V is equal to 0. When V equal to 0, as we have seen already here, this is what we have done here. When you short circuit here, we remove this 3K resistor and then we made this dependent source voltage short circuit. So to analyze this circuit, what we are going to do is this. So ISC is equal to 10 IE ISC is the current of dependence current source. So ISC is that direction and this is in that direction. If you write the Kirchhoff current law equation for this node, so minus 10I is equal to ISC, current that I would like to calculate. So you're going to calculate now this I current. I current is this current. Since this is 0, 8 over this resistor value, which is 10K, 8 over 10K is equal I. If you do this, you're going to find this in the short circuit current, which is going to be minus 8 milliamp. So we have found that ISC in the given circuit to us when A and B terminals are short circuited. Then calculation of RTH is VTH over ISC. So you can find the RTH. The RTH is going to be equal to this one. Okay. So this is the calculation of RTH. We said there is another alternative to this calculation, which is this. Let's see this alternative now. This is our Thevenin equivalent circuit. We have calculated this one. We have calculated RTH by using a method. Now this is the new method. New method, what we are saying is this. You're going to deactivate the independent sources in your circuit. If you do this in this equivalent circuit, that means deactivation of the independent voltage source means make the voltage of this independent voltage source 0, that is short circuit. and then apply a test independent voltage source between the terminals A and B, as we have done it here, and calculate I test. So this is independent voltage source, and we are going to calculate I test. From this circuit, we could say that RTH is equal V test over I test. So all I have got to do in my original circuits, I am going to repeat it what I did here on the left hand side. What it is, short circuit all the independent sources. In the original given circuit, I have got one independent voltage source. Deactivate this independent voltage source, make it short circuit, which is done here. And then put an independent voltage test independent voltage source between the terminals A and B. This is I just put in, and calculate that I test here. So I am going to find the I test current in terms of V test, and then V test over I test is going to be RTH. This RTH is the resistor that you see from the terminals A and B. So if you look at from here to the left hand side, this is the resistor that you're going to see. This resistor is the Thevenin resistor at the same time. So how we do this, this is once again, it is a circuit analysis business, but you're going to calculate only one current here, which is that current. So if you write these equations, so these are the current equations, so you could easily see it from the circuit. At the end, this has got VTS, V-test and V-test, two of them V-test, put it in V-test parentheses, then V-test over I-test gives you RTH minus 375, which has been found in this step here. That is the alternative one, and we found the same resistor value for the Thevenin equivalent resistor. So what we said is outlined here. So we calculate, now what we have done, see this calculation frame here. We have calculated VTH, which is Thevenin independent voltage source voltage, and we calculated RTH Thevenin resistor by using two different methods, and we found the Thevenin equivalent circuit. Because VTH calculated, RTH calculated, that means you can remove all these 5 elements and put those 2 elements. Nothing would change in the rest of the circuits. That means, here you are. So that is the circuit given to us, which is this. And I am replacing this circuit with this one, the calculation that we have found. VTH is 3 volts and RTH minus 375. So if I remove this and put that in, nothing would change in this load circuit. It could be an element or a circuit. If it is element, the current of this element, current and voltage of this element in this circuit, original circuit, as a load of this to this original circuit, or in this circuit, the load current and voltages as the output of the Thevenin equivalent circuit is going to be the same. Now, once we finish the Thevenin equivalent, so we are saying that we have already seen that there was a source transformation. So if we do the source transformation for the Thevenin equivalent circuit that we have already found, here you are, that's the original circuit. That is the Thevenin equivalent circuit to this one. If you do the source transformation, the circuit that you found after the source transformation is the Norton equivalent circuit of the original circuit. So the source transformation transfers this independent voltage source to the current source. The current of this independent current source is the 3 over minus 375, gives you that current, and the resistor in parallel, this serial resistor is going to be in parallel to our independent current source here. That is source transformation. This source transformation at the same time is the Norton equivalent circuit of the origin circuit. So we didn't mention how we are going to use the Thevenin equivalence circuit in circuit analysis. We are going to do it in the next video. In here we just showed you how to calculate Thevenin voltage and Thevenin resistance values for a given circuit. So that's the finish of this video.